Ever wondered what the heck the conservation of momentum is? Well, we've got you covered, because by the end of this video, you'll get to know the basics of what it's all about. Imagine hitting a baby with a bus. Now imagine hitting a baby with a bicycle. Now, ignore all legal implications. Keep this in the back of your mind, as we'll be coming back to this later. The conservation of momentum is very important because it governs how all things move. In fact, it's a very important law. No, not a legal law, it's a physics law. Rather than being created by humans, it was discovered that all physical objects behave by following this law. Okay, before we get on to the fun stuff first, we need to understand what momentum is and what conservation is, and then we can put them all together. Momentum is the amount of motion that something has while it's moving. In physics, momentum is determined by multiplying the mass of an object with its velocity. In other words, how heavy it is times by how fast it's moving. We can simplify all these statements into a small equation. P, momentum, is equal to m times v, mass times velocity. Alright, let's take a look at an example. Consider a car and a truck driving at the same speed. The truck has a higher momentum because even though they're traveling at the same speed, the truck has more mass. Now that we understand what momentum is, what about conservation? If I have 7 babies and you have 3 babies, there are 10 babies in the system. If I give you 1 baby, you'll have 4 and I'll have 6. The total number of babies in the system is the same, provided no one was stealing babies or adding in more babies, so it's conserved. The same logic can apply to the conservation of momentum. When 2 objects collide, the combined momentum before and after are equal, provided nothing was adding or removing momentum, like some external force. Remember before when we said to imagine hitting a baby with a bus versus a bicycle? If the bus and the bicycle are traveling at the same velocity, then the bus has more momentum because it's heavier. Now imagine they both come to a stop when they hit the baby. Because of conservation of momentum, all the momentum of the bus or bicycle is transferred to the baby. Do you think the baby will fly off faster when hit by the bus or with the bicycle? Spoiler alert, it's the bus. This is because the bus has more momentum than the bicycle. Since the baby remains at the same mass, where does the higher momentum go? It translates into the speed of the baby. And there we have it. The conservation of momentum. Important because you'd rather be hit by a bicycle than be hit by a bus. No babies were harmed in the making of this video.